Can you predict when you have a system or a machine outage in the future? And how much headaches and time and money would this save you? Aditya Baru, he's the Senior Product Manager at MathWorks, and he shares his experience on how artificial intelligence can help you preventing an outage, but also a headache. Aditya, welcome. And we appreciate you will be with us and sharing some insights how AI can help in predictive maintenance.
Thank you so much for having me, Ronald.
You're welcome. So systems or machine outages, they're causing a lot of stress within organizations, and on the other hand, they're very costly. Can you share some examples where AI-based predictive maintenance works best?
Sure, to first understand AI-based predictive maintenance, it's important to figure out the types of data involved in this process. You have images and you have sensors. And with both of these types of data, you can answer three types of questions. Is my machine behaving abnormally? So that's anomaly detection. Is there a fault in my system, and what's the root cause of that fault in my system, which is fault classification or root cause isolation? And finally, when is my system going to fail, which is the concept of remaining useful life estimation. Now, for each of these, you may be able to use image data and sensor data in different ways. For example, a major oil and gas company is using MATLAB with sensor data to predict when their trucks might fail. And they're doing this by collecting sensor data from their equipment, analyzing it using signal processing techniques, and then running the features from the signal processing techniques through machine learning models that can detect the presence of faults in their trucks. When it comes to image-based data, a major aircraft manufacturer is using MathWorks tools for deep learning, wherein they're taking images of components of their aircraft and running them through deep neural networks, which can detect the presence of defects in these images or the presence of faults in these images. Now, this is a much simpler way to perform these kind of tasks as compared to previously, when you might have had to go through the process of manually extracting features from images, figuring out what's going on in them, and so forth. But the ability to use AI, machine learning models, and deep learning models has made it much easier to solve these types of problems.
So you mentioned large airlines, large oil companies, but we see the use of AI in predictive maintenance in many different industries, small and large companies, and it's growing quickly. What type of challenges do you see in the marketplace related to this?
Definitely. I think to understand the difficulties associated with predictive maintenance, it's important to realize the process that goes into building a predictive maintenance solution. Engineers have to start by acquiring data. They then have to extract features from that data or reduce that data set, and then build a predictive model that can detect failures or predict when a failure might occur. Once they've built this predictive model as well, then they have to integrate it with their production environment, whether it's an IT system, an OT system, or anything else. Now, if you start looking at each of the stages in this workflow, there's a major difficulty associated with each of them. When it comes to data acquisition, it's really hard for engineers to get the right kind of data. Failure data is really hard to obtain because that's the job of engineering companies. Their job is to prevent these equipment from failing. So when it comes to developing a predictive maintenance solution, they don't always have the right kind of data. And that's a big problem, as you can imagine. Even if they were able to get that data, once they have it, they have to figure out how to reduce it to a much more manageable size. If you think about aircrafts, for example, or oil pumps, or any standard industrial equipment today, they generate anywhere between gigabytes to terabytes of data every single day. So when it comes to an engineer to analyze, and when it comes to a data scientist to build a machine learning model, it can be really difficult to process all of that data in a cost-effective and efficient manner. And that's where feature extraction and data reduction becomes really important. But there's way too many options for figuring out how to reduce these data sets in a way that retains all the useful information within them. Assuming you've crossed this hurdle of extracting features from your dataset, you then have to train a machine learning model. Now, while data scientists might be familiar with machine learning models, a lot of engineers, who are frequently the people tasked with building these solutions, they're not really familiar with machine learning techniques or deep learning techniques. So it's hard for them to get results. It's hard for them to figure out what kind of machine learning model they should use to build the right kind of machine, to build the right kind of predictive maintenance algorithm. And finally, once you have this predictive maintenance algorithm, the most important step is to integrate it into your production environment. Without integrating it successfully, you will not be able to achieve the benefits of a predictive maintenance solution. And because of the variations you see in the types of infrastructure, whether it's cloud-based, on-premise, hybrid systems, the number of edge devices a company might have, it becomes really complicated to integrate these algorithms into a production system from which you can reap the benefits of a successful predictive maintenance solution.
Yeah, and you indicate these 4 steps. How can organizations solve these type of challenges, and especially what type of skills and what type of tools are required?
So I think it's important to remember that at the heart of a predictive maintenance solution, you should have an engineer. They need to bring their domain expertise to the problem, which is what will help companies and organizations solve this problem effectively. For example, if we talk about the aspect of getting the right kind of failure data from their system, engineers can help with that. Frequently, engineering companies build models of their systems during the design stages. These models can be reused to generate synthetic failure data by injecting failure modes and faults into them. So this makes the process of gathering failure data safer and much more cost efficient. Because instead of letting an actual physical machine fail in the real world, you're instead breaking a virtual model of the same system, allowing you to collect as much failure data as you might need. Once you've obtained this failure data, the next step is to extract features from it. Now, here again is where the domain expertise of the engineer proves to be really valuable. They're the ones who understand what the machine is supposed to do. They're the ones with the experience in understanding how a machine's data might look if it's approaching some failure modes or fault conditions. And that knowledge is what has to be incorporated into a predictive maintenance solution. So getting to this stage frequently requires signal processing techniques, model-based techniques, modeling the system's dynamics, and so forth. And these are techniques that an engineer is typically familiar with. Once they've done that, the aspect of training a machine learning model is where engineers can use tools from companies like MathWorks, or they can work with data scientists who have more experience in this field. That allows them to experiment with different machine learning models and deep learning models to figure out what works best for their particular application. And as I mentioned, you can build a predictive model for detecting anomalies, classifying faults, or estimating the remaining useful life. And each of these 3 problems requires a different type of machine learning model in many cases. So trying all of these models out, seeing which one works best, is something that an engineer has a lot of expertise with. And when it comes to the deployment aspects, engineers need to necessarily work with the IT and OT organizations of their companies. These are the people who understand what their infrastructure looks like and how an algorithm needs to plug into it such that you get the appropriate benefits from it. So whether it's integrating with edge devices, whether it's integrating with ERP systems, or whether it's integrating with data historians, engineers need to work with their IT organizations to ensure that their algorithms are successfully integrated into a production system.
Aditya, thank you for sharing your experience and give us some more insights in how AI can help in the domain of predictive maintenance.
Thank you so much, Ronald.
And for the audience, thank you for watching, and we see you next time.